Let's find these two derivatives using the chain rule. If you haven't done this yet, then push pause and do this. Otherwise, follow along for the answer. On the first function, h of x is equal to 10 times the quantity 4x to the fifth plus 6x squared minus 14, and that quantity is raised to the 7th power. The way you should think about this is that you should think about this as 10 times something to the 7th power. And so when you take the derivative, what's going to happen is you're going to take the derivative of that something to the 7th power. It's going to cause the 7 to come out front. 7 times 10 is 70. The thing inside, 4x to the fifth plus 6x squared minus 14, gets kept on the inside alone. The exponent gets reduced to a 6, and then you have to multiply times the derivative of the inside function. The inside piece is the 4x to the fifth plus 6x squared minus 14. So the derivative of that is 20x to the fourth plus 12x to the first plus 0. So there is the derivative of h of x. 70 times the inside function to the 6th power multiplied times the derivative of the inside function. M of x, we should look at that and immediately think of 5 times a function to the 12th power. So as we take a derivative, the 12 is going to come out front, multiply times the 5. That will give me a 60. The inside function gets left alone and now is going to be raised to the 11th power. And then I'm going to multiply all of that times the derivative of the inside function. This inside function is a linear function. Its derivative is 9. A lot of times when I get an answer that looks like this, where we have a 60 out front and it's multiplied times a single number on the back, I will go ahead and do the multiplication just to simplify. So just take 60 times 9 multiplied times 9x plus 7 raised to the 11th power. And there you go. So that is how we take derivatives using the chain rule in these instances. You'll notice that in these instances, these were both chain rules that had an embedded part inside the power rule. But the chain rule works for more general functions as well. We'll look at that in the next videos.